chapter 4, day 2, because I don't really follow the book at this point. When I look at the chapter note page, again, hopefully we know that a quadratic is that y equals ax squared plus bx plus c. Actually, I guess we don't know that yet, so I apologize, but that will be getting filled in. Parabola is going to be the shape, that kind of U shape that I showed in the last video. The equations, the y equals, I can't even remember, like x squared plus 6x plus 8 or whatever. That's a quadratic equation, and it makes that parabolic shape. So those two equations, the product and the sum equations that we talked about in the last video back in chapter 1 as well, those are quadratic equations, and they make a shape of it, that U, that parabola. We'll talk about standard and factored form more as we go. We'll talk about factoring. Again, we talked about that a little bit, but we'll definitely go more into that. But today we're going to talk about initial factoring. So I have this process of factoring, these 5 steps that we're going to look at in chapter 4, where we do initial factoring, and it says a question mark because you can't always do initial factoring. And over my years of teaching, I just call it initial factoring. It's not like an official name or anything. It's all factoring. There's several different ways of factoring. Essentially, if you've ever bought ice in a bag, sometimes you know that the ice gets into one huge big clump, and the best thing to do is to take that bag and go crush it against the garage floor or cement floor, and it breaks that ice up into smaller pieces. That's essentially what factoring is. It's going to take a big clump of math and break it up into smaller pieces. We're not really changing anything. I mean, obviously you have just as much ice in that bag as you did before you broke it up, but it breaks it up into smaller pieces. So essentially that's the process of factoring. However, there's different ways to do it. And so we're going to start today with just this initial factoring. We'll worry about the diamond and simplifying if possible and writing factors and using the factors to get x-intercepts later. But again, right now we're only looking at step 1. Also, I want to draw your attention to a couple of other note pages. So this essentially is the quadratic parabola notes, and you can see we're starting in standard form, and the entirety of chapter 4 is to go from standard form into factored form so that we can get our x-intercepts. I'll talk about what the A means later, and but you can see an example where we have it written as a sum, and then we're going to factor it into a product. That's really the entirety of chapter 4. It's just going in this direction. We'll do a little bit where we're in factored form. We'll put it back in standard form. But again, we've already done that. That was in chapter 1 where we used the area model to turn it back from the product into the sum. So really, again, the bulk of chapter 4 is putting it into this form and getting our x-intercepts. Chapter 5, we'll look a little bit more at when it's already in standard form, what we can learn when it's in standard form. And then in chapter 9, what we'll do is we'll complete the square and we'll use graphing form. But again, this box will be answered in chapter 9. So I just want to, it's kind of a roadmap of where we're going to be filling in. And actually in chapter 5, you'll get another one of these with this section filled in. And in chapter 9, you'll get another one of these with this section filled in. Finally, I have this factoring quadratics. So you can see step 1 is the initial factoring if possible. So we're going to talk about this step 1. In this example, y equals x squared plus 6x plus 8. We could do no initial factoring. But on this one, we could do some initial factoring. And then again, steps 2 through 5, we'll go from there. Again, you're going to get another one of these in chapter 5. The one that you get in chapter 5 will have 3 extra steps. And those 3 extra steps will include different things about the standard form. And then you'll get another one in chapter 9, but it'll be completely different, and it'll be the steps on how to complete the square. So I know I'm throwing a lot at you, but really what I want you to understand is there's 3 different ways to write these equations. We're going to talk about 2 of them in this chapter and next chapter, and then we'll introduce a third one in the following chapter, chapter 9. All right, so that is a lot of words, many fine words. So what I'm going to do now is I'm going to start with this worksheet and just talk about initial factoring. Now, this is something that in my childhood we did in junior high. I get the feeling they don't do it in junior high as much as they used to. But it's the exact opposite of distribution. And here's what I mean by that. As a matter of fact, to get this worksheet, I literally took a distribution worksheet and took the questions out and left the answers. So this is like the answers of a distribution worksheet. But if I were to, what I'm doing is, actually I guess what I'll do is I'll say, here's the distributive property. Hopefully you guys all recall this. So if I multiply 3 times 2x, I get 6x. And if I multiply 3 times 5, I get 15. So again, this would be a product, this would be the sum, these would equal each other. Well, what if I wanted to reverse that, and instead of multiplying, I wanted to divide? Hopefully you see I could divide a 3 out of a 6 and a 3 out of 15. And if I did that, 6x divided by 3 is 2x, and 15 divided by 3 is 5. So when we start here, let me kind of clean this up a little bit. So if I were to rewrite this as 6x plus 15, this process going from here to here is known as distributing. This process going from here to here, I call initial factoring, but really it's just a way of factoring. It's one of the several ways of factoring, but for our terms, we're just going to call it initial factoring. And we need to be comfortable with this initial factoring before we learn how to do parabolas. And again, just over the years, I've noticed kids were really struggled with the initial factoring part. I just kind of assumed they knew how to do it because I knew how to do it in junior high school. So I'd show it to them once or twice and think they were good, and they weren't. So this is crucial. If we can't do this, we really need to be reaching out and asking questions and making sure that we know what we're doing, because it's going to make chapter 4, 5, and 9 miserable if we don't. So if I look here, I know that I can take a negative, right? They both have a negative to give. They both have a 6. 6 goes into 6 once. 6 goes into 48 8 times. You'll notice I can't take an a from both of them. I can take an a here, but I can't take an a here. And I have to be able to take something from both of them. So negative 6 is the most I can take. Now, if I divide negative 6a by negative 6, think about it. What's left is just an a. And if I divide negative 48 by negative 6, a negative divided by a negative is positive. 48 divided by 6 is 8. So this is what I'm going to be left with. Now, the way you can check your answer is you can distribute to see if you get right back. And remember, distributing and factoring are opposite operations. So negative 6 times a is negative 6a. Negative 6 times 8 is negative 48. There we go. This is factored. And again, I want to make this very clear if I can. The original worksheet had this as the question and this is the answer. So what you're looking at right now is the answer key. And I just took out the questions so I could change the worksheet from a distributing worksheet to a factoring worksheet. So let's go ahead and jump down to something like 4. What number can I take from 18 and a 20? Well, hopefully we all recognize that 2 would be the biggest number, right? Sometimes 1's the biggest number, but I want to take the biggest number I can. So let's take a 2 out. I can't take an m from both, but 18 divided by 2 would be 9. I don't want to forget this m. And 20 divided by 2 is 10. So 2 times 9m is 18m. 2 times 10 is 20. So this must be my answer. Again, I did the reverse of distributing, so I can check with distributing. I'm going to show you a question like number 5, because I think 5 is an interesting question. That was unfortunate that I did that. All right, so what happens, I'm going to tell you right now, the biggest number I can take out of both of these is 8. But let's say I don't see 8. Let's say the biggest one I see is a 2. So I'm going to take a 2 out. Well, I hope you realize, hey, look, I can take another 2 out. And then you think, oh, look, I can take another 2 out. They're still both even. Well, that's fine, but what's 2 times 2 times 2? 2 times 2 times 2 is 8. So you can see there's my 32 and there's my 24n. So even if you don't recognize immediately what the biggest term that you can take out is, even if you didn't recognize that you could take an 8 out first, let's pretend you noticed the 4. So you take a 4 out, and then you go, oh shoot, I can still take another 2 out. You should still end up ultimately back at the same answer, 8 times 4 plus 3n. So I just want to show you that it's okay if you kind of mess that up. Another thing that you might be asking is, what if we do a question like 8, right? What if we just take a 6 out? So if I take a 6 out, I'm left with negative x minus 4. But what if I take a negative 6 out? Then I get x plus 4, right? This is minus 6x minus 24. This is minus 6x minus 24. My advice to you would always be to do it this way. You want to take the negative out if you can. That would be my advice. Or I guess what I would say is I was always trying to leave this variable as positive. So on this one, I would probably take a 4 out and leave it as 7p. Wait, what am I doing here? That's not 7p. As 6p minus 7, right? 24p minus 28, because now this p is still positive. So my preference would always be to make this one positive if I could. So that's an initial factoring. You can see you get some opportunity here. So again, just to kind of reiterate what I was saying, I know I want this to be positive. So what if I take a negative 5 out? Now I'm going to get 10x plus 1, negative 50x minus 5. There's other ways you can do it, but I always want the variable left in the parenthesis to be positive if I can. So I hope that makes sense. It's just going to make the parabolas that we do, these following steps, it's going to make it easier if we leave that term as a positive x. It'll still work the other way. It's just more work.